So we did some questions of the application of a resolution of vector, and why the resolution is necessary, because we cannot add numbers until they are numbers. I mean, the vectors always represent a directional value, and we know that if two things are in two different direction, there is no numerical addition possible for those things. Of course, we have some vector addition methods available, but that is only meant for representation, not meant for calculation. So there is a difference between representation and calculation. So how resolution helps? It gives us the values in one particular direction, and every values in one particular direction can be added together using simple algebra. And then once we are done with the addition part, we can recombine at the end using the idea of vector components. So let me just recap the part that we started with. So what I gave was one force vector acting at some angle with x-axis, and it's in a two-dimensional plane. You can say this is f vector. The corresponding length of this vector we called f, and now we can drop a perpendicular from the f to the x-axis. So wherever it will intersect on the x-axis, the length which you measure from the origin, that is called the x component. And if you draw a perpendicular from the point tip of the vector to the y-axis, whenever it will intersect, the distance from the origin is called y component. So this we can say fx by notational value, and this is called fy. The x and y are called subscript. Okay, so I hope I have discussed the subscript part. It's just for the better informative representation of values. So when I write fx, I'm saying that the component of f in the x direction. And so when I'm writing fy, I'm saying component of f in the y direction or parallel to y direction. So that is the idea of writing in this particular way. Using trigonometry, you can write easily. What you can write? Cos theta. And cos theta will be how much, guys? Tell me. What is cos theta? In any triangle?
By hypotenuse.
It's a.
fx
What is the
upon
base here? Yeah, fx upon.
Fx.
Right? So similarly, what is sin theta?
Fy by
S.
So you can see clearly that the x component can be determined given the net magnitude of force and the angle, or you can say direction. And similarly, the fy we can write as f sin theta. And now triangle will allow you to write the f vector as fx into I cap, which is the direction of fx, and fy into j cap, which is the direction of fy, the y component. And the fx, if you want, you can rewrite as f cos theta and f sin theta, like this. Given a vector, magnitude and direction, we can express as a sum of two components, and these two components are very interesting because these are mutually perpendicular. And what I said that if the components are mutually perpendicular, they are independent. And what does it mean? It means the one component cannot in any way affect the other. So these are like two independent events happening together and creating a net event, which we call force. Based on this, we did the resolution for other vectors also. So what we did, in case of something called projectile motion, if you throw something, it goes up, comes back to the ground. And imagine if you are throwing at some velocity v naught, and let's say the angle is theta. So if I call this as x and this as y, then the x component of velocity can be at vx. So what will be the value of vx, guys? Tell me. You can see this is the velocity vector having magnitude v naught and direction theta with the x-axis. What will be its x component?
Sir, V cos theta.
V naught cos theta. How we read this? This is read as V naught. This is how we read V naught. Okay. Okay. So now the Vx we can write as V naught cos theta. So what about Vy?
V naught sin theta.
So basically this is, if you remember, V naught cos 90 minus theta. If you again recall that what we take is the angle between the vector and the axis in which you want the component. Okay. But once you resolve into two mutually perpendicular components, no need to resolve further, because these two components can recreate the given vector. So these are the sufficient condition to recreate the V naught. So you can think this way. It is like the V naught and Vy, the Vx and Vy together creating V naught. This is the how you think. To give you a simple example, you can think this way. So let's say there are two subjects in your school, physics and maths. Now, the performance is something which depends on the score which you obtain in physics and maths boards. Okay. So we have a vector called performance vector. And see, this is the vector. This is the vector called performance vector. And the tip is telling you that how much you have scored in the maths and how much you have scored in the physics. Or you can say this is the total score vector. That better way you can say total score. So here you have obtained some value in maths and some value in physics. So let's say maths you got 90 and in physics you got how much? 60. Yeah, that's very less. Okay. So your total score is a vector having two components, 60 and 90. That's the whole idea. So in a way, if I want to know what is the total score, I can have this sufficient information. 60 and 90 are sorry, 60 and 90 are sufficient to recreate the total score. So we say that 60 and 90 are the components of total score vector. Okay. So that's the whole idea. Like if V naught is the velocity, then the V naught cos theta and V naught sin theta are the components, and these two components are actually can recreate the vector V naught. Okay. So now tell me guys, how to get V naught given Vx and Vy? What is the reverse process? Can you guess? So let's say instead of vector, someone is giving you components. Can you recreate the vector? And if yes, then how? Am I audible?
Ah, yes.
Yes.
So
Yes,
what
sir.
is given to you? What is going to use Vx and Vy? This is given to you. So your total score is not given, rather the individual scores are given to you. Let's say you got in physics Vx, in maths Vx and in physics Vy. So what is your total score? How to get the total score? What we should use? Which theorem?
Oh, we'll add, no? Oh,
No, it's a vector. Now let's say your score is a vector score. It's not a, scalar score. Okay.
oh,
So
so we'll get the hypotenuse.
yeah, and you know how to get the hypotenuse, right? It's not very difficult to get the hypotenuse. Given the component is like they have given you the side length of the base and the perpendicular, and finding the vector is like finding the hypotenuse, right? So how to find V naught from here? Tell me, guys. How to get V naught back? Come on. How to
Yeah,
get V
so
naught?
it should be, if it's the Pythagoras ka theorem, so it should
Yeah.
be root of Vx square plus Vy square.
Exactly. That's correct answer. So given the component, we can recreate the vector by squaring and adding the, and that is the benefit of mutually perpendicular. Imagine if the world is not, if the coordinate system is not mutually perpendicular. The difficulty is not like impossible to create the new physics. I mean, of course, we can create. The only difficulty will be the complexity of writing. So here you use the Pythagoras. Imagine if it is not right angle, what we need to use? Something called cosine law. So that's not a very convenient thing to use than using the Pythagoras, because we all are comfortable with the Pythagoras, isn't it? So our mathematical journey is quite simplified if we somehow creates a system in which the Pythagoras is sufficient to derive everything. Okay. So one part you have done with your logic, and that's correct. The squaring and adding the component will give you the V naught. Now you guys tell me with your own logic again, how I can get my theta back given the component. Think about it. What kind of manipulation you should do to get back to theta?
Theta being angle, right?
Yeah, exactly. So what should be your strategy to get back theta? You know what is given. You know what is given is Vx
So
and Vy.
tan.
Exactly. So what we'll do is you will divide it, right? Because the moment you divide, the V naught will vanish because we don't want it. And that's very logical choice. I'm not doing it because I'm forced to do it. I'm doing it because I know it's very logical. So there are 3 ways in which it can be done. And so in total 6 ways, but we'll always go for the method which is the most convenient to us. So I will rewrite the equation which is known to us. V naught cos theta was Vx and Vy is how much? V naught sin theta. And I'm trying to get back my theta. What I can do? I will divide the 2 dividing 1. So if you divide the 2 by 1, what we get? Vy upon Vx. Let me write the other way around. So may I write a tan theta equals to Vy upon Vx? Is it okay, guys?
Yes, sir.
Yes, sir.
So theta is
Yes,
equal to tan inverse Vy upon Vx. Okay. That's the whole idea of tan theta. I mean, or you can say theta. Understood? So theta is tan inverse Vy upon Vx. It's like inverse is a method of writing in mathematics, and it gives the angle. So tan inverse is like an operator, and when this operator operates on a number, it gives another number which we interpret as angle. Okay. So these are the method which we employ everywhere, not only in this case. No matter what is the situation, if you know the 2 components, which are mutually perpendicular, then they are sufficient to give back whatever you need. So what we need here is we need the squaring and adding to derive the actual value, and again we need the ratio to get back my angle theta. So that is how we proceed in every question. The same thing you could have done for the force also. So may I write the F equals to under root of fx square plus fy square? May I write?
Yeah, you can.
Yes.
And similarly, can I write that theta equals to tan inverse Fy upon Fx?
Yes, sir.
So you can see, given a component, you can go and get back your actual answer. So if you want your answer, let's say x and y. Let's say if I write a very simple vector, let me write down this very famous and very simple vector called the position vector. Let's say we have a position vector something like this, y and x, and this is simple vector we call r vector. So definitely the tip is actually representing a point in space, right? Okay. So tip is representing a point in space, and we can call it x and y because it's a two dimension. And what you can do next is you can drop a perpendicular. So once you do this, you know exactly that this is x and this is y, right? So how we write the r vector? X I cap and y j cap, because the directions are parallel to x and y axis, isn't it? We have done this before, and this is a theta. So we know already this. So here x is the x component, y is the y component. So what is the value of r? How to get back r value? So given x and y, can you find r? So that's very straightforward. It's a Pythagoras itself, right? So once you square and add, what you get is the length of the r vector. So how to get the theta again? Tan inverse y by x. We have done this before. We are doing it again for the sake of completeness. Understood? And what right now seeing you is called the polar system. So in two dimension, let me introduce this system here only. In two dimension, there are two systems. One is of course the Cartesian, which is for 2 and 3 all. But for two dimension, we have one special mathematical coordinate system, and that is called the polar coordinate system. Now, what is the purpose of using any system in mathematics? And why we need to use all this system? So that we can express the point in space with the help of some number. Okay. So let's say I want to represent this point with the reference to this line, the bottom line. This is called the reference line. Please do remember, the reference line need not to be x-axis. It is just the name of the line, the reference line. In polar system, we don't have any other thing. We just have only one line. And the beginning is called the origin. That's it. So let's say I want to go from origin to point P. How to achieve this? So to go to point P, first of all, from the x-axis, what I will do is I will turn by some angle. Let's call theta. And once I will turn theta, I will move forward till I reach this point. So how many variables we need to reach the point P? One theta. And once we have turned theta, follow the path by traveling r steps ahead. So once you do this, where you will find yourself? At point P. So how to write the coordinate of the point P? We don't write x and y. What we write?
Excuse me, sir.
Yes, yes. Tell me.
I just come in 1 minute.
You can go and come. So for any reference line, given a reference line, if you want to locate a point in a plane, how many variables do we need to achieve that? So we just need two variables. In Cartesian, we call the variable as x and y. So in polar system, what we call? r theta. How we read? R theta. This is called theta.
But angle can be anything. No?
It must be in radian. Okay. So of course angle can be anything. These are two numbers, no? R is a number.
No, no,
Yeah.
no. My question was that like angles can be from anything till 90 in this case.
It could be any
So-
value. Yeah, it can be even
Yeah.
270, 380, and maybe 1000 also.
Yeah. So my question was like, if there is a smaller value, how will you display it? So is it in degree or radian?
No, we always choose the radian to display the value. Okay, because radian is a number, and degree is the called division. It's not a number. It's like a relative. It's a way to represent things. Okay. For example, if we this is for 180 degree, right?
Yeah.
But the meaning is if I have a maybe some sort of scale, and if I divide this entire angle into 180 equal parts, then each part is called 1 degree, right? So 1 degree means 1 division. You're dividing the line by some random lines. Okay. Radian is not a division. Radian is actual the way we measure the angles. Okay.
Okay, so thank you.
So radians is the measurement, and degree is one of the way to represent the things. Okay. And that's why when we say radian, we always mean some number, some real number. Okay. So no matter how small it is, you have to do the same process from reference turn around. If let's say theta is 0, it means you are on the reference. Okay. So r and theta are the a way to represent the point in space only when the point is in 2 dimension. Now we would like to connect this system. We would like to connect this system with the Cartesian system. So I want to know that are these two systems related? The answer is yes. So if I draw or if I choose the reference as my x-axis, now this is a separate assumption, and the perpendicular as y-axis, then clearly we can correlate the r with x and y, right? So this is x and this is y. And can we say x is nothing but the r cos theta? Can we say x is r
Yeah.
cos theta? Can we say y is r sin theta?
Yes, sir.
And again the same thing. Given x and y, can we find r and theta? See, given r and theta, we got x and y, isn't it? Given r and theta, we got x and y.
Yes.
So there must be a reverse process.
Yeah.
Given x and y, can we get r? So if you want to get r, what will do here?
Sir, Pythagoras.
You will square and add these numbers, right? X square plus y square is how much? Correct? You
Yes,
are
sir.
basically squaring and adding, and we know that this is how much?
1.
1. So now you know why we do this. Okay. Why the Pythagoras is coming indirectly. So given the values of x and y, we can get r, which is nothing but the same thing we did here using the vector definition. And for theta, what do you do? You divide the values. So theta turns out to be tan inverse y by x. So you need to know the polar system in mathematics also, in physics also. Our kinematical equation will be using the polar system. Also in class 12, there are many chapters which uses the polar system like electrostatics, magnetism, and so many other chapters. So polar system is a system that we should be aware of. There are many other systems definitely, which I will introduce at the end of this chapter, like a spherical coordinate system and cylindrical coordinate system. These things you will study in the BTech first year. So having a basic idea will definitely help you in future. Now, anyway, this was just a recap that what is and why we do the resolution. And time has come to do some real problem. Okay. So let me give you some problem. And our heading will be, let me put a heading. Finding the resultant force. So let's say there is something like a plank, a wooden plank, and multiple forces are acting at different location. So one is acting this way, other is acting this way, and one is acting this way. Let me take some other force. So how many forces are you seeing right now? All arrows are force. So how many force we have?
So
4.
4.
4. So let's take a value. So let's call this as 10 Newton. Let's say 12 Newton, 5 Newton, and let's say 8 Newton. Okay. Let's say this angle is given. Okay, how much is good? Okay, keep it 60. So how many force we have here? Okay, if you want, I can do one more. Maybe like this. Like this. So let's say this is maybe 14 Newton. You can use calculator for calculation. If I give some bad angle then. Okay, so I think good enough. I have given. Now you're supposed to find the net force acting on the body. Okay. Find. Okay, that's written. Find the net force acting on the body. Find net force So first thing first, force is a vector or a scalar.
Vector.
So vector cannot be just added like numbers, right? We cannot add vectors like number unless they are in the same direction. So do you see any vector in the same direction here? Any vector you do see as parallel vectors?
Yeah.
Which one?
10 and 8 Newton.
Correct. Very good. So 10 and 8 are parallel vectors. Are they in the same or opposite direction?
Opposite direction.
Opposite
So
direction.
do we need to add or subtract?
Subtract.
Subtract.
Definitely. So I mean, we at least we know the net value of these two. The 10 and 8 will give you 2 only. But the problem is that is not sufficient. We have a vector of 12 Newton and 40 Newton acting at some angle. And when something acts at some angle, it means it will have some component, right? So to add vectors, first of all, we need to resolve into component. But to resolve into component, we need to choose proper coordinate system. So now I'm not going to tell you anything. You will tell me what your logic says, like what your common sense says, that what will be the right choice of x and y axis. Should I take x axis like this and y like this? Is it a good choice?
No.
Definitely.
No.
See, I mean, mathematics is very natural. If I'm telling you choose proper x and y coordinate because you want to resolve things, you are free to choose, but you must choose something which is convenient. And again, I'm saying there is nowhere in the history of mathematics which says that you must take x like this and y like this. There is nothing like this written in history. I can choose x like this, y like this. The only condition is these two should be mutually perpendicular. I can choose x like this and y like this. No one can stop you. So you don't get trapped into this illusion that x must be horizontal and y must be vertical. X and y are just two random lines which are mutually perpendicular, and that is the only idea we have to stick with. But anyway, my question to you is, Do you have some choice to offer to me? So you must take X like this and Y like this, which is convenient. So what will be your choice? If I'm giving you freedom to choose, how are you going to suggest me? Tell me.
So we can take X along the plank.
Very good. So that's a very logical choice. I mean, I will appreciate this. Someone choosing X like this. Again, let me make it very clear. It's not mandatory. It's a logical choice which facilitate the writing. Okay. So, okay, if I choose this as X, then I have no choice left with Y. Let me take Y. How I can take Y? That's okay. That's correct.
Yeah.
And it really doesn't matter. Now I will tell you the key secret. The X and Y must be drawn for every vector. But all X and Y must be parallel to each other. What does it mean? Because the force is not located at only one point. So you may have a difficulty. So to deal with, draw X and Y here at the tail of every vector. Always. Always. Why? There is a reason. Until you will not draw the X and Y coordinate at the tail of each vector, you won't be able to see the quadrant. Okay. So you can clearly see that 12 Newton lies in which quadrant?
First
First
quadrant.
quadrant.
But the 14 Newton lies in which quadrant?
Fourth.
Fourth
Fourth
quadrant.
Very good. And the 8 Newton?
Along y-axis.
Along minus y-axis. Yeah. And 5 Newton?
Positive x-axis.
Positive x-axis. And the 10 Newton?
Positive y-axis.
Right. So every vector doesn't need to be resolved because they are already well resolved. Our end goal is to resolve things along X and Y only. That's it. And therefore, out of these 5 vectors, only 2 are not aligned. And therefore, I must take their component so that we can make the eventually addition or subtraction. So let's start writing. Before we start writing, let me name all such forces by giving some name. It's good to easy to write. Let's call F1, F2, F3, F4, and F5. See, it's very convenient to use the subscript based writing. So when you write something with subscript, it's more informative. So we have 5 forces here. So what is the vector losses? How to find the resultant? So resultant finding is same as adding all vectors. Okay, you don't add scalar, you can add only vectors. F1 vector. So how many vectors do we have? 5 vectors, right? Okay. Now, because you have the proper already assumption of X and Y axis, you are now free to choose I cap and J cap method of writing. So tell me guys, how should I replace F1? By writing what?
10 J cap.
Excellent. So what about F2? F2 is in which quadrant?
First.
First quadrant.
F2 is in the which quadrant?
Fourth quadrant.
Fourth.
Fourth quadrant, right? So if F2 is in the fourth quadrant, then its X component will be positive and Y will be negative. Am I right?
Yes, sir.
So what you are supposed to do is you simply resolve along the nearest X and nearest Y. And because you know the nearest Y is whether it's Y or minus Y, accordingly put the ing. So can I say the 14 cos 30 will give me positive I direction? Just take the arrow and turn, you can realize, right? So
Yes,
this
sir.
vector will turn like this, no? So now this, if you rotate from here to, if you rotate till the x-axis, the arrow is pointing in which direction? Plus x.
Yeah.
So we write this cos 30 I cap. But if I resolve from here to here, I will write 14 sine 30 or 14 cos 60. Which direction?
Minus J.
Minus
Minus
j
j.
cap. Very good. So let's write down. If you want, you can write separately, and I'm writing at the same time. So can I write f equals to, tell me if I'm wrong, 14 cos 30 I cap and 14 sine 30, which is same as I think cos 60, minus j cap. Tell me if you have any doubt in this.
Sir, no doubt.
And plus, who will tell me f3?
So 12 cos 60 I cap.
12 cos 60 I cap. Excellent, very good. And
Plus,
then
plus 12 sine 60 j cap.
excellent. Okay, now only two are left, which is I think easy. So f4,
5 I cap minus 8 j cap.
yeah, so f4 is minus 8 j cap. I can write minus directly. Basically, it's 8 minus j cap, which you can also write as minus 8 j cap. That's totally okay. And then plus 5 I cap, and we're done. Okay. Now it is like we have broken the vectors into two mutually perpendicular direction, and it's like we have two separate number lines. So which component can be added together? Can we add all the I component together? Yes or no, guys? Tell me.
Yes.
Yes,
Yes,
sir.
sir.
And can we add all the j together?
Yes.
Exactly, we can. And therefore, the next step is the logical step, separate the components. Okay. So I'll write 14 cos 30 I cap. Okay. Then 12 cos 60 plus 5 whole I cap. And you can see this is now you're adding simple numbers, which is like a simple algebra, the algebra which you know. And what you're learning right now is called the vector algebra. Plus, let's tell me, I mean, separate the j values. 10 minus 14 sine 30 plus 12 sine 60 minus 8 j cap. See, I got the net f value. So quickly, if you can add and tell me the values, you can use calculator for adding them. Yeah, because the cos 30 is root 3 by 2, so you need some fraction. So can you just tell me the answer for the after adding everything? Tell me, guys, quickly. What else I need to do? It's 14.
So the J1 would be 5.392 j cap.
Okay.
Sir, I is 7 root 3 plus 11.
30 plus 12 plus plus 5. So I'm getting the I cap as 23.12, right? And how much J you said? I mean, you told me something, right?
So 5.392.
Okay. Correct. That's a 5 point. So eventually, now this is the number. Now, what does it mean? I can represent this on a graphical way. So tell me, guys, my resultant is in which quadrant? First, second, third, fourth. Can you guess?
First.
Sir, first.
Exactly.
So first,
Okay, and which value is bigger, the x or y?
X.
X.
It's almost 4 times, isn't it? More than 4 times, correct?
Yes.
So let me just do a better one, more accurate. 1, 2, 3, or 4 almost in here. Just a minute. Let me exchange this. So if I take the fourth 4 part in this side and 1. So it is slightly more than 4, right? 23.12 divided by 5.392 is 4.2. It's slightly more than 4. That's correct. So your graph will actually, the F will actually look like this. 4 times the component will create 4 here and only 1 here. It's so much inclined. Let me make it slightly bigger. So do you see this? This is the F. So all force adding together will create an effect which looks like this. And now I'm always interested in the direction of the resultant. That's my always interest. So how to get the direction, guys? How to get the direction? We know the method. Given the x and y component, see what you know here, x and y component. So given the x and y component, do you know how to find the theta?
Yes, sir.
So what's the method of getting theta given the component?
Tan inverse y by
Sir, using tan inverse.
Yeah, so the theta will be tan inverse y component upon x component. Do you realize this, guys, what I'm saying?
yes.
Y
Yes, sir.
component upon x component. So what is the y component upon x component? How much is this?
0.23.
Great. 0.233. Okay, so what I'll do is I'll use the inverse function. Tan inverse, how much is it? 0.233. It turns out to be roughly 13 degree. Yeah, degree value. It is roughly 13 degree. And you can see clearly the angle is really small. It is 13 degree. Okay. So now we have done this question, so I'll just put into theory. To find the resultant of any vector, let's say if I say the F is, so the resultant is also called the net force, and it turns out to be you add all the x component together and you add all the y component together. The tan theta you can always write as mod of Fy and the other method is like what the other step is, take modulus as of now and interpret the angle by drawing the proper coordinate. Okay, how? Let's say numerically if this turns out to be plus and this plus, the answer must be in the first quadrant. But what if this is minus, this is plus? Which quadrant, guys? Which quadrant?
Second.
Second. So what I will do is I will do my F vector like this. I will take my theta here or you can say I will take alpha here, and I will find the alpha using the this relation, because I just need value first. But once the value is known to me, the angle the vector will make is this angle, and theta we can write as pi minus the value. Okay. So the quadrant we can choose, and we can interpret this part we have done for R vector. We can also do it for any other vector. Okay, guys. Okay. So you might have heard about something called momentum in your high school. Anyone who has not heard about momentum? And the symbol for momentum we write as P vector. So guys, tell me, what is P vector?
Sir, M into V.
M is scalar, V is a vector. So we write M into V vector. So momentum is simply defined as the product of mass times velocity. So I am believing that you know this formula. And if you don't remember, just look at it right now. So I have a drone, and using the drone, I see the aerial view of a school compound, let's say, in which kids are playing. And if you think of every kid, so they are moving in the random direction. Let's take only 4 kids, because you need to do the calculation. So this kid is having mass, okay, how much? Let's say 40 kg. And let's say velocity is not very fast, 2 meter per second. So the future ocean board. And let's say this is a mass of 35 kg. And this makes an angle of, let's say, 60 degree. And velocity is, let's say, 3 meter per second. And this guy is moving, let's say 30 degree. Mass is 45 kg. And moving with velocity 4 meter per second, quite faster. And the last 45 degree, 40 kg is okay. Can we have 25 kg in school? I don't think so. Let's make it 50 kg. And the speed, let's say 5 meter per second. Oh, the athlete of the school. Anyway. So if I ask you, what is the total momentum of the system, which is same as finding the resultant or net value. So find net momentum of the system. Can you do this?
Yes, sir.
So what you have to do is choose the proper XY coordinate. And I know logically what we'll do is, and then solve. And remember the rule, we must choose the XY at the tail of each vector, right?
Yes.
So please proceed, write the values and tell me the answer. However bad the calculation may be, make sure that you have the patience of writing, because JEE is all about bad calculation also. So this is just like a practice for, writing practice, like how much patience do you have. Hello guys, are you done?
Still doing.
Number it 1, 2, and what I want is P equals to P1 plus P2 plus, that's it. And the mass is the number, so you just need to resolve the velocity.
So I'm getting the answers in decimal.
That's okay, that's okay, that's totally okay. Yeah, so
So
what's the value?
minus 239.8 I cap minus 176.37 J.
Minus 176, right?
Yeah,
Point
0.3737 J.
there, which simply means the net momentum of the system is pointing in which quadrant, guys?
Third quadrant.
Third quadrant, right? If I draw the x and y axis, the answer is, and roughly it is quite close. I would say the x is slightly bigger than the y, so it will be slightly like this because the difference is not much. So this is the p vector. Okay, and the moment it is not in the first quadrant, I will call this as alpha. So what will be the tan alpha value? Alpha is just a number, just a value, and I'm taking this alpha, which is the acute angle. So you just take the value and tell me what is tan alpha. You can write as Py Px. Just take the y values and x value, take the ratio and take it modulus because we just need value. We have already identified the quadrant. So once we know the value, we can express the answer eventually. So tan alpha is how much?
0.735.
So alpha we can attest either tan inverse this value. Now, what is the angle made by the vector with the positive direction of x-axis? Because we must remember the angle of a vector we express in terms of angle it makes with the positive direction of x-axis. Now, there are two ways of writing, either this way or this way. So, which way we should go, clockwise or anti-clockwise?
So clockwise.
Right. Because the anti-clockwise exceeds 180, right? And as a rule, we don't take angle which is bigger than 180. So this we call, so the angle will be how much? This is how much value wise? Pi minus alpha. Correct?
Yes, sir.
So how we write the theta? Minus to represent clockwise with value pi minus alpha. So whenever you turn clockwise, you have to mention by putting a minus sign. Is this clear, guys? Angle cannot be negative. Angle is only angle. So when you see the angle with sign plus or minus, what you need to understand is that they are saying this kind of signal or it's kind of indication to you that turn clockwise instead of anti-clockwise to arrive at the vector. Okay. So technically, there is no harm if you write 180 plus alpha with plus sign. Technically, there is no harm, but as a tradition, what I said, that angle should be kept between minus pi to plus pi. So whenever we have the angle exceeding 180 in one direction, we reverse the direction. And whenever we reverse the direction, we make sure that directional information is encoded in mathematics. And how we encode this direction? By putting a minus sign. I hope this part is clear to you. Anybody else getting the answer minus 239.8 and 176.37?
Sir, I'm getting something different only.
Okay. Can you confirm what you're getting?
Sir, for I cap, I'm getting minus 131.7 I cap. And for J, I didn't calculate.
Anybody who has calculated J cap also? Devang, have you done this calculation? Vedant, sorry.
Yes, sir.
Have you calculated the value?
Yeah.
How much you're getting?
I haven't. I mean, it's still
Simplified.
in. Can I use calculator or no?
Yeah, you can use.
Oh,
For
Acha.
J cap, I got minus 289.35.
Okay. So there are many values. Minus 289.
Yes, sir.
Anybody else getting some new answer? Okay, I'll just confirm because we should not go without proper calculation. So let me do this calculation here quickly. Calculation is the integral part of a learning for preparing for JEE. If you are scared of it, oh, that's really bad. So never be scared of it. And right now I'm giving you the liberty to use calculator, although it's not required, but it's good to use so that you can save time as of now. Okay. So let me do the calculation quickly. It is 35 into 3, 105, right? And minus cos 60 I cap and plus sin 60 J cap plus, you can add here 2 45 into 4, 180, and minus cos 60 I cap and minus sin 60 J cap, or you can say cos 30 plus 40 into 2 J cap. The last is 250 1 by root 2 I cap. Yes. If these are your component, then you should get the right answer.
Sir, first one, it should be 70, right? Instead of 105.
It's 3, na? It's 35 to 3.
Oh, 3. Ah, sir, there I went wrong. Sir, I thought it was 2.
And nevertheless, that's you know the method, that's okay. Maybe some it's a writing problem from my side. I think I wrote a really small, which confused you. So 105 cos 60 is the first item, and minus 180 cos 60 second, And then I should add cos 45. That's better. Whole I cap and 105 sin 60.
Sir, first one will be 17, na? 35 into 3,
How much?
75.
Ah, that's 25.
Ah,
okay.
yes, sorry.
So 105 into sin 60. See, I always say to my student, you know what? The most challenging part in physics in JEE preparation is, you know what? What is the most difficult part of JEE preparation? This. You know what it is? Any guess? This is the challenge. If you can command these four mathematical operations, you can master physics. Okay. Now you will be laughing. What is this? I know this. So I hope you all know this addition, subtraction, multiplication, division. Are you sure? Okay. I hope you should be sure only. Else it's dangerous. So what you will learn that with time that the only mistake will commit is calculation mistake. So 2 plus 2, 4, 3 plus 2, 6. Am I right? 3 plus 2 is 6. Is it right or wrong? Tell me, guys.
Oh, it's 5.
Oh, it's 5. My bad. Okay. Now, this is what I'm trying to say, that this is the kind of mistake you will commit. And 5 is the right answer. Make sure that every time you get 5. So this turns out to be a very weird answer. The 4.27. Okay. Can you guys confirm? Just in case I'm wrong. Because I don't know addition, subtraction, multiplication, division till so far in my life.
Sir, it's fine. No need to solve this. So we got it.
Okay, so this is minus 1. No, I just wanted to confirm the value. So this is actually in the fourth quadrant, right? Just let me change this answer. So finally, we got the answer, and this is in the fourth quadrant. And x is really small, y is really big. So it will look like, sorry. And let's call this as alpha. So the theta will be how much? Minus alpha. That's it. Because I cannot turn like this. It's too big. Anyway, so this is how we write the angle, the direction, and the magnitude. We'll do some more practice, of course, and we'll practice for the equilibrium problems. So we'll start with some simple problem just for practice. Sorry. So you can see there's one force acting this way. And third force is acting somewhere here. I don't know. So there is a random body kept at the origin, as you can see. So this is the random body kept at the origin, experiencing three forces, in which two are known and third is not known to us. Okay, two are known and third is not known to us, but it is given that the body is at equilibrium. So given that the body is at rest, find the third, or simply find the unknown force and force magnitude. Okay, let me put it like this: magnitude and direction. I hope the question is clear to everyone. What we are trying to achieve here. What is given to you? Tell me, guys. Three forces are given to you. And how many are known to you? Only two. And what they're asking? The third force. And what we mean by equilibrium? When the resultant is
0.
0. What does it mean? The sum of F1, F2, and the unknown must be a null vector. Correct? So what we are trying to find? The unknown. So can we write minus of, you can shift on the other side and see, it's very simple. We do not need third. Given the first two, you get the answer, just put a minus sign, you get the third one. So can you solve now? Can you solve now?
Yes, sir.
So go ahead and try this question and tell me the correct answer with proper calculation. You can use your calculation as of now. Everyone, you must attempt. See, I want to see on everyone's notebook. I may check randomly and I may force you to send me the solution. Don't say that, sir, I was doing on bathroom, so I don't have the. If you're doing in the bathroom, take a picture and send me. So my session would be do it on the paper. Everyone.
Yes, sir, done.
So what is the answer? Tell me.
So minus 30 I cap plus 41.96 J cap.
Minus 30 I cap
Yes, sir.
and
And plus 41.96 J cap.
plus 41.96.
0.96.
Yeah. J cap. That's not possible because okay, you're saying minus like this. Right? You're saying this answer minus of entire thing.
No, sir. Actually, I think I made a mistake.
Okay, so I think I'm right. Addition is difficult.
Sir, I got the answer as minus 30 I cap minus 20 J cap.
Minus 30 I cap and
Minus 20 J cap. So not like the bracket is not applied. It's minus 30 I cap minus
yeah.
20 J cap.
But it cannot be the perfect number, no? It should be some decimal, right? I can see clearly it's a decimal. Okay. I think you guys getting confused. Tell me, guys, what is F1 vector? How to write it? What is F1 vector?
Sir,
So
10
10
J.
J cap.
10 J cap. Excellent. And what is F2 vector?
60 cos I cap minus 60 sin J cap.
60 cos.
I cap.
60 cos what angle?
Cos 60.
60 cos 60 I cap, right?
Yes.
And
Minus 60 sine 60 J cap.
very good. And we're done, no? So you just add this first. Okay. So 60 cos 60 is 30 I cap. And 60 sin 60 will be 30 root 3. Okay. Minus 10. So 30 I cap and 30 root 3 is how much? 1.732 into 30.
51.96.
Very good. Minus 10. So 41.96, right?
Yes.
So the F vector is how much? Minus of this, which is minus 30 I cap. And plus
41.96 J cap.
Sir, even I got the same thing.
just am I doing some mistake? Okay. 60, this should be negative only. Yeah, that's fine. Yeah. Okay, my bad. So that's correct. So this is the answer, which means okay, this was the answer. This is the right answer. So the third force should have. So the angle shown is wrong. So third force should be where? Minus I plus J, something like this, right? So we
Yes.
need third force something like this to balance it. Maybe something. Just that's fine. Don't have space. So the third force shown was not correct. But anyway, we have to find the directional force both. So to find the magnitude, what we can do next? How to find the magnitude, guys? Given the x and y component, what we do?
So square root and then square.
Yeah, so we squared that's 30 square and 41.96 square. How much is this coming? Anyone? Please guys tell me, help me with the answer. What is this coming?
So root of 2660.
You can take the root, right? So it is coming 51.58, and you can see the J is positive, X is negative. Which quadrant? So this is the third quadrant. So what is the alpha value in the third quadrant? Can we find the alpha? You can find the alpha by taking the ratio in terms of 41.96 upon 30. This turns out to be 1.398, which is roughly at 1.4. So alpha turns out to be tan inverse of 1.4. So roughly it is coming 54.46 degree. So what is my theta? So we always take the angle from where? From the positive direction of x-axis. So this is my angle. So my angle is how much, guys? Tell me. 180 minus 54 point. I am writing in degree here. Okay. So this coming how much? 125.54. Okay. So this is the angle made by the vector, the third vector, and the magnitude turns out to be 51.58 roughly. Okay. All right. So I'll give you some tricky questions which you can solve almost mentally. Let's see. There are two forces acting like this. One is acting at 30 degree and other is and there is a third force acting somewhere. I don't know how exactly. And we have the random body kept at the origin. So find the magnitude of unknown force such that the body remains at rest. Again, solve this. Anybody solving this question?
Yes, sir, I got it.
How much?
Sir, 70.19 Newton.
Oh my God.
Sir,
Sometimes we are lucky. So this is like called the tricky problem. Sometimes we need not to do all the hard work, as we always think. So how we can write F plus, let's call this as F1. Let's call this as F2. So can we write F plus F1 plus F2 equals to null vector? Am I right?
Yes.
yes, sir.
So can we write F equals to minus F1 plus F2? And because we are looking for modulus, so can we taking modulus both sides? And once you take modulus, it's the same thing. And modulus is nothing but a resultant of two vectors. So why to use the component? You can do it directly. What is the formula? A square B square 2AB cos of theta between them. So what is the angle between A and B? F1 and F2? Can you see it's 90? Guys, can you see the angle between the F1 and F2?
Yes.
Yes, sir.
Yes, sir.
So that's very much visible, and that takes away the burden of doing anything. So 30 square, and this is just Pythagoras because these are mutually perpendicular, so we can just use Pythagoras. Or if you want to use the formula, you are most welcome. What is cos 90, guys?
0.
This term is 0. So eventually this is 30 square plus 40 square. How much? 50 square, right?
Yes.
So when we have only 3/4 in which 2 is given and third is not given, component is not always required. If you know the angle and if it is a nice one, you can do it this way also. So that will save your time in the examination. So that is called like being smart in the examination. Of course, you can do by the component, and those who are doing by component are doing really good job because you are commanding the concept of component. But be ready that you may have some surprises in the examination like this. Okay.
Yes.
Now,
Yes, sir.
if I ask you direction, then component is the nice one, right? Here it's very difficult to find the direction, right? Okay, imagine I want to find the direction without using the component. What I can do? Any suggestion from you guys to me? Okay, you don't want to suggest your teacher, huh? Okay, appreciable. But I can draw a parallelogram. That is the basic, right?
Yes.
And we know that the resultant is the diagonal. Done. And I can find this angle. Pretty easy. How much, guys? Tan theta, because this is 9. So what is tan theta, guys? I mean, let's take it alpha. What is tan alpha? Tell me. 30 upon 40.
Yeah.
So 3/4 is very famous actually. It's 37 degree. If you don't know, that's okay. But this is 37 degree. Okay. So what is the angle made by the resultant vector? Because our vector should be opposite of this. So if this is the resultant of these two, the third force must be opposite of this line. Exactly here. Okay. So this is alpha, which we know. This is 30. So what is this? What is this angle? Oh. What is this angle, guys? Tell me. That's called beta. Can we find beta now? Yes, we can find. Why? Because these three angles, alpha, 30, and beta, will make it 180 degree. Do you realize this?
Yes.
Because the resultant is opposite of the resultant of the first two vectors, and that should be. And therefore, I can find beta also. So I can say alpha plus 30 plus beta is 180 degree. So I got my beta 180. Sorry, minus alpha minus 30, which is how much?
113 degree.
113 degree. Okay. So we know the final answer is theta is minus beta, right? The way of writing. Because we have to move we have to move clockwise to reach here, right? So from the x-axis, if I move clockwise, I can get this answer. Does it make sense to you guys?
Yes.
This
Yes,
is called the tricky part. Let's say every time, of course, we have method, but in JEE, if you look at the question, most of the JEE question comes with some subtle trick, and if you will click, you can solve in seconds.
So can you please explain this part once again?
Which part? The angle part.
The direction.
Yeah. So direction is, this is the resultant of 1 and 2. This is called F1 plus F2 vector. But if you look at vector form, what is F hour? What is F? Come on, guys, tell me what is F? Minus of F1 plus F2, right? So what is the meaning of negative of a vector? A vector with same magnitude in opposite direction, isn't it? If three forces are at equilibrium, can we say that the resultant of any two force is balanced by the third force? I think it's difficult. No? So we have three forces, and we know the net force is 0. So any one force will be minus of the other two, isn't it?
Yes, sir.
So
Yes,
I have written something. F equals to minus of F1 and F2. So where is my F, guys? Tell me. My F will be opposite of the resultant of F1 and F2, isn't it?
yes, sir.
Look at this. My F will be, this is the F1 plus F2. So my F will be opposite of this, exactly like this. Am I right, guys? Tell me yes or no.
Yes, sir.
Yes, sir.
So what is this angle, whole angle?
180 degree.
So out of 180, what I know? Alpha. What I know? 30. So can I find this value?
Yes, sir.
So I call this beta as of now. And using the relation, I can find beta. You can check here. Okay.
Yes, sir.
So once we have beta, which is 113, how we write the angle, how we express the angle in vector? We express the angle by taking or by turning from the positive direction of x-axis. So to reach here, I can either turn whole this much, which is not allowed. So how I'm going to turn? So tell me, guys, my turning is which direction, clockwise or anti-clockwise?
Clockwise.
So clockwise.
And for clockwise turning, how we write the answer? With minus sign, right? So beta is a numerical value. And to show to the world that I have obtained this answer by turning clockwise, I will put minus sign. I hope this is clear, guys.
Yes.
Okay. So yeah, a bit of challenges here, but with practice you will realize that this is very interesting actually result. whenever three vectors are at equilibrium, if you add any two, it will be equal in magnitude of the third and opposite in direction, because that is the only way. No? So we can say in general, if sum of sorry, if sum of three vectors, okay, is null vector, then f1 we can write as minus of the other two, but you can also write f2 as the minus of 1 and 3, guys, and f3 we could sorry, write as minus of. So what is it the takeaway? What we learned from this simple discussion? That if three vectors or three forces, basically, if the three forces are at equilibrium, then any force will be opposite to the resultant of the remaining two forces, but they will have same magnitude. So what is the modulus of f1, guys? Tell me. May I say modulus of f1 is nothing but the modulus of the remaining two?
Yes.
May I say modulus of f2 will be nothing but the modulus of 1 and 3? May I say the modulus of the third will be nothing but the modulus of the 1 and 2? Tell me yes or no, please, come on.
Yes, sir.
Yes, sir.
I need your approval. Then only I can proceed. If you have understood, we can proceed. So now comes the very interesting and very powerful concept in vector, and that is called the equilibrium of three equal forces in value in a plane. So we'll find that condition for equilibrium of three coplanar, of course they must be plane, coplanar. This is very important. This is like dangerous. You must remember this result. So condition for equilibrium of three coplanar forces having equal magnitude. So there are many ways to prove it. So I'm giving you a way which is simpler. So what is given is okay, solution. Given that f1 vector is equal in magnitude of f2, is equal in magnitude with f3, let's call it f. Okay, so this is the first condition as obvious from the question itself. Am I right?
Yes.
And now I have to write a condition which is called the mathematical condition, which talks about this value. So how to write the equilibrium, guys? Okay. So let angle between f2 and f3 is theta. Okay, and what is given to us? Okay, that the three forces are at equilibrium and they are equal in magnitude. So I have written those statement into mathematical notation, and I hope you are getting it. If not, do let me know. So are you realizing that how to convert the language into a symbolic language? Both are the same thing. The above is called literature, a pure literature. The second one is called the symbolic literature, literature which you call maths. Basically, maths is basically being able to convert your emotion into symbolic notation. That's called mathematics. So in math, we do nothing actually, and that's very interesting. But still, we have to keep on expressing ourselves till we get exhausted with the ideas, and then we get some simplified the resultant expression. Okay, anyway, that's very deep. So let's say the angle between 2 and 3 is theta. I would like to know theta. Tell me guys what I can do. Can I write f1 equals to minus of f2 plus f3?
Yes.
Yes, sir.
Taking modulus both sides. If you take modulus both sides, what will happen?
Mod of f1 is mod of f2 plus f3.
And we know the formula for the resultant of two vectors, isn't it? So what is the mod of f1? F. And what is this value? Under root of a square b square plus 2ab cos theta. Am I right, guys?
Yes, sir.
So if I square both sides, what I can get? F square equals to. Okay, let me write down squaring both sides. Okay, for the first time I'm writing, and maybe the last time. I will not be writing like this again. Squaring both sides. F square is how much? 2f square plus 2f square cos theta. And if you rearrange, what you will get? Do you realize this?
Yes, sir.
And therefore, the theta is exactly 120 degrees. Now, do you realize this?
Yes, sir.
Okay, that's the value. Cos theta is minus half, theta is 120 degrees. Just remember as of now. Okay. Later on in Chigo, you will learn why all these things comes. Now, because of symmetricity, can I say the angle between the other pair will be same? Without solving, can we say? Because it really doesn't matter whether I choose one left and 2, 3 right, or 2 left and 1, 3 right. I'm going to get the same answer. Okay, isn't it? So can we say that if I choose any random pair, 1, 2, or 2, 3, or 3, 1, the angle must be 120? Yes or no?
Yes, sir.
So what you learn from here? If the three vectors having equal magnitude are at equilibrium, then they must be forming this beautiful symmetry city. And you know what is this? Anybody? The Mercedes symbol, right? Have you seen this?
Yes, sir.
So it says that okay, the car is so stable that it is in the perfect equilibrium with design or their philosophy. They have their own philosophy. I'm just trying to give you some relation why we draw something like this. And there are many applications. You can see if you look at the ceiling fan with 3 blades, you will see exactly at 120 degree each. Do you see that? They're equally inclined. Okay, don't see. So do you have ceiling fan at home? Okay, you need to switch off, then you can see. Okay, yeah. So 120 degree each is very common. You can see everywhere. So if we have vectors which are equal in magnitude, and if we have 3 vectors particularly in equilibrium, always remember that each angle will be 120 each. I hope you will remember this answer. Now we have the fairly large number of question of Newton's laws of motion, which you can solve using the component method. So I will show you some question which we'll practice here before we move to the next concept. So we started such question in the last lecture, but today I will try to finish some of them. So this is particularly from the Newton's laws of motion. So I represented something called the string problem in the last lecture, if you remember. The naughty problem, yeah, now I remember. So anybody remembers that, the naughty problem?
Yes, sir.
Yes, sir.
So how many of you want to get rid of vectors in your life? You really don't like it. Many one don't like vectors. Anybody who don't like vector at all? I mean, you really like numbers and this vector is like disturbing the entire. So if by any chance, if you don't like vector, make sure you love it. Because you may leave you may leave vector chapter, but vector chapter will never leave you. It is going to be part of your life throughout. And you know what is the most important application of vector? Any guess? Where we use vector most?
Sorry.
In which domain we use vector a lot? The world is depending on vectors, you know.
Yeah, you will use vectors almost in any chapter, no?
Yeah, not one chapter. The entire machine learning, artificial intelligence is based on vector. Now that is something more intriguing. So we don't realize that how this simple concept is, or you can say, has become a pain for the full world, like not half. Those who don't like mathematics, they will find it very difficult. But if you like vectors and mathematics, you will have quite a lot ease. Okay. So now this is the question, and I named this as naughty problem because of the knot. So how many strings, guys, you can see string?
Two,
4. We have only 3
Three.
strings.
two. Oh,
We have 3 strings. Okay, it's not about color. It's about like where if you join something, it becomes a separate part. Okay, so even if you touch, it becomes 2 string. Let's say if you have a 1 string, and if you touch here, someone is touching here, they're touching here, it's a 4 string now. So in that way, you can think it's a 3 string, right?
Yes.
So we don't see physically, we see logically. So logically, it's 3. Physically, it may be only 1 piece that you have turned around like this, or it could be 3 pieces, it could be 2 pieces. I mean, I don't. So our discussion is based on the logical meaning of string. Now, The rule is these are called lightweight or massless strings. Like they do not have much mass to be bothered about. And what we are hanging is some block, some cylinder of mass M. Okay. Now gravity will pull the block or the cylinder in which direction? How gravity works? It pulls
Down.
towards the, downward direction. You can say vertically downward. And the value of gravitational force we write as mass into gravitational acceleration, the G, which you might have heard somewhere, maybe in high school. The G is, the G is 9.81. So the gravitational force that with which the cylinder is always being pulled is m into G. First thing first. And the thread or the string develops tension as a result of that. So when you try to stretch a string, so there is a difference between the rubber and the string. If you have a rubber band, they are stretchable object. Now in physics, in laws of motion, we assume that strings are inextensible objects. It means you cannot stretch theoretically even by 1 millimeter or 1 micrometer. So these are logical assumptions. Okay, don't worry that in real life you may pull a string by some few centimeter, maybe few millimeters, and so on. So we are learning a purely ideal system of assumption, and we say that our strings are inextensible. So we deal with inextensible strings. And what is the property? What is the property of such a string? The moment you try to pull them or stretch them, they become taut in a way. They create a force within themselves to stop you. Okay. And such force is called, what we call the force?
Tension.
Tension force, right? For experiment, you can pull your earlobe and feel, is it developing some tension? Yes or no? Try to pull first. Anybody pulling?
Yes, sir.
Yeah. So is it developing some tension?
Yes, sir.
And what is the tendency of the earlobe, to go back or to get stretched?
To go
So to
back.
go back.
Yeah, exactly. If you try to pull your hair, then what will happen? Hair strand. Pull some hair strand. Is it trying to pull you back or pushing you?
Pull back.
Exactly. Let's say if you shake hand with each other, with any two person, and if you try to pull each other by holding hand of each other, okay. So the tension will act on both of the person in which direction? Let's say someone is pulling each other, okay. Or let's say in a tug of war. If the team A is pulling the rope this way and team B is pulling the rope this way, how tension is pulling both the teams?
Sir, inwards.
Yeah, so A will be pulled like this and B will be pulled like this. So the tension force, which we represent by symbol T generally, it will only pull you back, which means the general property of a string is simple. The ends of the string is always capable of pulling itself back whenever it is taut or whenever someone is trying to pull it. Then only, of course, if there is no tension, if no one is pulling, it will never come back. Okay. So with this idea, because we have three separate strings, logical strings, let's call the tension developed in the first string as T1. Let's call the tension developed in the string 2 as T2, and the bottom is T3. Okay. Now the direction of tension is also very simple. How it acts? It always acts away from the connection. Wherever it is touching something, it will always try to pull the two ends of itself. That's simple. So if I talk about the first string, can you see the two ends for the first string?
Yes.
And what is the property? It will pull inward. So it will pull the upper end like this and lower like this. Does it make sense? Guys, tell me yes or no.
Yes.
Look at the second string. How the tension will pull? Will it pull like this and like this? Yes or no?
Yes.
The upper end down and the lower end up. And look at the third string. How it will pull, guys? The upper end in which direction? How this third will pull the upper end? Tell me, guys. For the third string, how the tension will pull this end?
So downwards,
Exactly. And the cylinder?
upwards.
Exactly. So now you know how things are pulled. So I hope the pull part is clear for everyone. Yes or no?
Yes, sir.
Anyone having doubt, because this is something very interesting. In fact, of course, the same thing I will be explaining in the laws of motion chapter. But if you can understand here, it's really good. You can save your time. So anyone having any doubt, you can raise your hand. Not an issue. I will explain once again. That's totally okay for me. Prashansa, Rugved, Shreya, Siddhant, Vedant. Tell me, guys.
Sir, no doubt.
No doubt. Anybody? Okay. So I can move forward.
Yes, sir.
So let me redraw because this is too messy. So I'll draw it separately. Okay. So again, I will draw here itself. So before before coming to here, maybe in high school, whenever you might have solved any physics problem, it had some numbers, right? Numbers like 10, 20, 15, whatever. And you were comfortable with the numbers, right? But now, what we need to understand is answers can be without numbers. We can have something called symbolic answers. Okay. So now you have to learn a new way of writing answers. Answers in symbol, let's say alpha, beta, mg, and so on. And I will not give you any number, 10, 5, 20 will not be given. Because such questions and such answers are very much prevalent in the entire physics. In JEE Advanced also, mains also, most of the questions will have symbolic answers, except the numerical answer type question, that's called the NET questions, or integer type questions. Earlier it was used to call integer type questions. Just for your reference, I am saying all this. Keep in mind, it will help you in future. Okay. Now, how we solve the naughty problem? You can see clearly that these three forces called T1, T2, T3, are these three forces, are these forces creating any motion? Is the knot moving or swinging here? The answer
No,
is
sir.
no. So I will particularly draw a proper, see again, this is my choice and that's logical choice. I can draw a proper coordinate system taking the knot as the origin, but that is a logical choice, and the y-axis. You can also realize that, okay, this is actually logical choice of taking the x and y-axis, isn't it?
Yes.
And the moment we draw this, we are at ease with many things. For example, I know what is this angle. What is the angle?
Alpha,
Very good. And what is this angle?
beta.
We call it alternate angle, right? And we also know something about these forces. So we know for the knot, T2 is acting this way. And for the knot, T1 is acting this way. Am I right, guys?
Yes.
Yes, sir.
And for the knot, T3 is acting this way. But at the same time, the same tension is acting on the block upward, correct? So for the block, T3 is acting upward and gravity is acting downward. So we'll first start with the block. So we'll discuss about block and then we'll go back to the knot. Do you see the block moving, yes or no? The block is at rest, yes or no, guys? Tell me.
Yes, sir.
And if the block is at rest, can we say the net force must be 0? And how many forces the block is experiencing as of now?
2.
And for resultant to be 0, these two forces must be equal and opposite.
Yes.
Yes, sir.
So they are opposite, which is obvious, but they should be also equal, isn't it? Because if mg will be more than T3, it will go down. And if T3 will be more than mg, it will go up. But it is neither going up nor going down. Can we say T3 must be equal to mg? Yes or no?
Yes, sir.
So that's called the equilibrium of block. So that's the first case. Equilibrium of block. And block is under the action of just two forces. And because these are balancing each other, can we write, and do you see all forces are in the vertical direction? So I can take the P3 as positive and mg as negative because it's acting downward. And the sum of these two must be null vector or 0. Am I right, guys?
Yes.
Yes, sir.
Yes, sir.
I'm not writing j cap because of the obvious reason. We know that the answer is in the j direction. So there is no confusion. So I'm not writing j cap. Okay. So this will give you the answer T3. So earlier T3 was not known to us. Now do we know T3? The answer is yes, we know T3. It is m times g. Okay, guys. So far, any doubt?
No.
Now comes the knot. At knot, all the three forces are balancing each other, right? Okay. At knot, all the three forces balancing each other. Can we say in vector form? T1 vector plus T2 vector plus T3 vector must be null vector. Can we write like this?
Yes.
Which is same as writing, and if you because see every force can be resolved into x and y. Okay. So we can also convert these forces into x and y component, and then we can add them all the x component together and y component together. So what we know from the component thing that if the net force is 0, if net force is null vector, can we say the net component should be also 0 individually? Okay.
Yes.
So let's say you have 3 apple and 5 banana. So what is the total amount you have? 3 apple and 5 banana. Man, of course, apple and banana cannot cancel out each other, right? So can we separate apple with banana?
No.
Can we add apple with banana? No. So I cap coefficient cannot cancel the j cap coefficient, isn't it? Even though they are negative, I mean opposite with minus sign. So 10 I cap minus 10 j cap. Can we write 0 here?
No.
That's wrong, entirely wrong, because they are not same. We cannot subtract. So when something like this will be 0, if I write something I cap and something j cap is null vector, when it is possible? When this is possible?
When both x and y components are 0.
Exactly. When both boxes are independently 0, this is also 0, then only we can say it's null vector. Because this will never cancel this, so both must be 0 separately. And that is why when the net force is 0, either you can write vector form and add them the way we have done before, or you can also say that this must be 0 and this must be 0 independently, separately. That's very interesting about mathematics or the components. These components cannot affect each other. So if I am 0, it means I am 0 because of myself. The x component is 0 because of itself. The y is 0 because of itself. X will be not 0 due to y, and y will not be 0 due to x. Okay. So now there are two ways of solving this question. One is you write each vector in ij, 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 and add them and separate I, separate j, and then equate to 0 each term separately and solve it and get the answer. The other way is, why don't you only take the x component at first for everyone and take the y component for everyone and then solve it. And the third is for beginners, like anyone who starts learning this component thing, I give something called tabular method. Just for you guys, for first time and last time. Because after spending some time with this method, you will stop doing this thing because you know you can do it without any support. So what we do is we draw something like this, a box, a kind of table or chart. So as in the beginning, it will help you. I mean, oh, this is not too much. How much I need? I just need 3, right? So how many vectors we have? How many forces we have? 3. T1, T2, T3. Okay. So what we are going to do is we are going to write the component in box, just the value. Value means, of course, plus minus we have to take care. So, okay, look at this. T1 is in which quadrant, guys? Tell me.
Second.
So which component will be positive and which will be negative?
Y will be positive, x will be negative.
Excellent. So what you are supposed to do is y will be positive and x will be negative. And now just write the value. What is the value of component? Can you see the component? What is the x component value wise? T1 cos alpha, isn't it?
Yes.
If you remember the resolution of vector, you can say this is T1 cos alpha. If you have any doubt, please do raise your hand. So what will be the y component, guys?
T1 sin alpha.
Very good. So who will tell me the second one? T2. If you have the diagram, tell me, guys, what is T2? Which quadrant is T2?
So first,
First quadrant.
And in the first quadrant, both component will be positive or negative or what?
Both will be positive.
Can you tell me what should I write for X and what should I write for Y? What is the X component of T2 in the X direction?
Sir, T2 cos beta.
Correct. In the Y component?
T2
T2
sin.
sin beta.
Excellent. So I am just writing T2 cos beta and T2 sin beta. Okay, I'm left with the third. Okay, third is simple, I think. Who will tell me the answer? T3 is acting in which direction?
Minus y.
Exactly. So what is the X component?
0.
And this is minus T3, right? And we are done. Okay. So what we write here is, let's add all three values. You will get T1 cos alpha, T2 cos beta, plus 0. And let's add this value here. What we can write? Okay, guys, so we are done with the component. We have the component ready with us. What is the condition for equilibrium? For equilibrium, each component must be 0 separately, isn't it?
Yes.
Any doubt in this? Because this is very important. For equilibrium,
No
can
doubt,
we
sir.
say that fx and fy must be 0 independently? Yes or no?
Yes, sir.
And once we have this, then we solve, because see, T3 is known to us. So only variable is T1 and T2. So we must express the answer. So let me write the question first. So this equals to 0 implies minus T1 cos alpha plus T2 cos beta must be 0. What does it mean? So we got the relation T1 cos alpha is T2 cos beta. It's a really nice relation. And similarly, T1 sin alpha plus T2 sin beta equals to T3. I'm writing directly, that's okay. And this I can replace by mg. Is it fine? We had the relation earlier. Tell me, guys, if it is okay or not.
Yes.
So anyone having doubt in this, guys, please tell me.
So why don't we take mg as minus mg? Because it's in the minus direction.
No, mg is the value which we have calculated, right? Mg is the value, no? So we are writing T3. What is T3 value? You can see while deriving, I have written, no? T3 minus mg value is 0. Mg is not negative. Mg is the value itself. What is negative is the way of writing.
Okay, sir.
Every symbol which you're looking right now is value. And we are putting plus minus as per their direction, which I am choosing. Okay. So should we write T3 or minus mg? T3 is mg only, no? Can you see here? T3 and minus mg is 0. This is a positive number, and this is a negative number. These are numbers. These all are numbers. Okay. Tell me if it is okay or not.
Yes, sir.
So now we have two set of equations. This is equation 1, this is equation 2. And we have two variables T1 and T2. Alpha, beta are variables or given values? Alpha, beta are known or unknown? Here alpha, beta are given or unknown values. Tell me, guys.
Sir,
Sir,
unknown.
unknown.
No, alpha, beta are given to you. Don't worry. What was not given is the tension developed. Okay. So alpha, beta are given to you, and you can use in writing or expressing your answer. What is not given to you? T1 and T2. So now you can see there are two equations. How many variables we have in these two equations? Can you guess?
Sir, 2.
So two equation, two variable. Can we solve as per rules of mathematics?
Yes, sir. Simultaneous.
Yeah. So who will solve? Everyone. Please go ahead, guys. Solve it and tell me the answer.
So what is the alpha beta value?
Yes, you have to use alpha, beta, sin, cos, and everything. You have to express the answer without T1, T2. T1 in terms of mg alpha, beta, and T2 again in terms of mg alpha, beta. So
Okay.
take your time, solve this simultaneous equation, and get back to me when you're done. Okay. So I'm giving you 5 to 6 minutes to solve, everyone. I hope everyone is trying this question at least. Don't sit idle. Don't wait for my answer. Keep on doing the hard work. Okay, guys, done? Yes or no? Anyone getting the answer? Okay. Let me do this. T1 sine alpha plus T2 sine beta is mg. I have this relation. I can replace T1 in terms of T2 or vice versa. Let's say I'm trying to find T1 first. I must replace T2. How I connect T2? T1 cos alpha upon cos beta, right? Into sine beta equals to mg. So now you can take T1 common. Sine alpha plus cos alpha sine beta upon cos beta is mg. Take LCM. So what you can get is sine alpha cos beta plus cos alpha sine beta. You can express the answer this way also. But after learning some bit of trigonometry, so sine alpha cos beta plus cos alpha sine beta. This is a nice way of writing, of course. Even if you're getting this answer, this is correct answer. But after learning trigonometry, you will come to know this formula is called the angle sum formula, and this we can rewrite as sine of alpha plus beta. But that's not an issue. Even if you don't know this, that's totally okay. So sine A into cos B plus cos into sine B, we write as sine A plus B. Okay, guys,
Yes, sir.
it is clear.
Yes.
So similarly, if you try to solve the T2, the beta will be replaced by alpha. That's it. So now why this was difficult? Because it has no number, right? And your intuition is good with numbers, but not with symbols. This is the first challenge that you will come across in JEE preparation. Dealing with symbolic answers. So this is the answer actually without number, right? So don't worry, with time you will get accustomed to this. It will not pose any threat. So in the beginning, we all are not comfortable because from high school, when we come here for the JEE preparation, we had that habit, and then leaving that habit and learning this new habit will take some time. So just keep patience, everything will be okay. Trust me. So is this clear, guys?
Yes, sir.
Before we end today's lecture, I would like to solve one more problem, and then we can wrap up this entire discussion. And next lecture, I will start the product of vectors as a separate topic. So here is the second question. So this is a cylinder. And we have two support. So these are two fixed supports on which the cylinder is balancing itself. So definitely gravity will try to pull this down, right? There is no option. Okay, so gravity is trying to pull it down for sure. So you can see there are some corner touching the cylinder, and whenever the corner will touch the cylinder, it will create a force called the reaction force. And there is a particular name for it. We also call normal reaction. But even if you don't know all this terminology, is just totally okay. Some force will act that we can realize, yes or no.
Yes.
So cylinder at the corner will experience some force. Can you guess the nature of force? Is it push or pull for cylinder? The cylinder will feel some pressing force or some pulling force.
Pressing force.
Correct. And the force will actually, if you extend the direction of force, it will pass through the center. Why? Because if you draw any perpendicular to that circle, it will be passing through the center. That's a angle between the tangent and the radius, right? Again, even if you don't know this, totally okay. And this force, the push from this side, will also push the center by some force. And you need not to worry much because everything will be given to you. And what will be given to you? This angle is alpha. This is beta. You want to write bigger? And these two arrows representing some force. And since you don't know their name, let's name it. Can we say this as N1 and this is N2? It really doesn't matter. So I'm just giving some name because technically these are called normal reaction. And traditionally we use the N symbol to represent the normal reaction forces. Just like technically or traditionally we use T for writing tension force. Again, it's not a mandatory thing. It's just a logical assumption. So now given the angle and gravity, can we say these three vectors are balancing each other? N1, N2 and mg. Can we say, guys? Yes or no?
Yes, sir.
So first of all, to solve this question, you need to choose the proper coordinate system. So what I will do is I will choose the point of intersection of these three forces as my origin. Again, it's logical. And then I will draw the x and y axis logically. So this will be the x. And once you make such assumption, you will be or you should be in a position to write the angle that these vectors are making with the x and y axis. And the next step is resolve every vector into x and y component. Add all the x together equate to 0. Add all the y together equate to 0. And then solve these two to get n1 and n2. Of course, the answer will be in terms of alpha, beta, and mg. So you can take a next 20 minutes because this is the last question anyway. But make sure that you do the rigor to get the answer. So try your best to arrive at the answer, no matter whatever it takes. So your time starts now. I won't answer till 9 p.m. You are free to use your time. Those who solve early can leave early after informing me the answer in private. Okay. Those who will not solve will stay with me till 10 o'clock. And even if you're not able to solve till 10 o'clock, you can stay with me till 11 o'clock. So no matter how much time it takes, you have to solve. 1 hour, 2 hours, up to 3 hours. After 3 hours, definitely I will leave you so that you can have your dinner and all. Okay, so start you guys.
So can you go to the previous page once?
Yeah. Yeah, or before that.
So this one. Yes, sir. Thank you.
So you solve and leave. You don't solve, stay. And everyone has to submit the answer on WhatsApp separately. Okay? You just WhatsApp me, not in the group. And then only you can leave. Rugved, you got the idea how to solve?
Yes, yes.
See, you have to practice. There is no way out. In JEE preparation, the beginning struggle will only help. If you try to escape right now and think that the future will be everything okay, that's not the case. So spend as much time as possible for vectors, kinematics, laws of motion, and after that, the entire physics is piece of cake. It's just like applying those fundamentals again and again. Yeah, so that's one equation. But if you use the other equation and substitute the value and then rearrange to get N1 and okay.
Okay.
So to find the T1, substitute T2 in terms of T1 in the equation and solve.
Sir, I've sent the answer. Can you check?
Yeah, just- No, you haven't solved. Look, wait, you are just trying to manipulate. You're not solving it.
Okay.
Yeah, but that's correct. Question answer, it's correct.
Yes.
So now you can leave.
Thank you, sir. Bye. Sir.
Bye, take care. Yes, Rugved.
Sir, can you give one more question like this?
Yeah, there are many actually. Uh,
Sir, I had one more doubt.
yeah, tell me.
So in the previous sum, why did you like while solving, why did you take T2 sine B and then you took T2 as T1 cos alpha upon cos beta?
Because this is the relation. Where is the answer? You can check this relation. So from here, what I can write? T1 is how much? T2 cos beta upon cos alpha.
Okay, yeah, got it.
This is what we are using. We are using this to substitute the answer.
Okay,
So I'll give you, in fact, I'll send you a few questions today only in the group so that everyone can practice. Okay.
okay, sir. Thank you.
Bye. Take care. Yes, Rugved.
Sir, I sent.
Okay, I think what you're doing is, let me tell you. Can you show me the step before this?
What?
Show me the steps you have written, like the kind of calculation you've done throughout to get this answer.
Uh,
Show me.
it's,
I know you haven't written, right? You've just written this
I
answer.
have written,
No.
but it is
Yeah.
messy.
No, that's it. I can give you message. Okay. Just the y component is positive. You have written negative.
That's why I got the earlier answer. Then I corrected it, and then I got this answer.
So how you corrected this? I mean, minus n1 cos beta is not there, na? It's n1 cos beta,
And one.
and then n2 cos alpha
Yes.
minus n2 equals to 0.
Hmm.
So make it change it, and then show me how we got the answer. Then because if you do one small change or one mistake, it will give you a different answer. Okay,
Uh,
just do it one step, make it final answer, proper answer without any mistake.
yes.
Okay, you
And
can do it. It's like if you want to escape, you see, let's say if you don't want to learn this, you can leave, not an issue. But if you want to learn it, you should stay back and you should solve. In fact, you should say that, okay, so no, sir, I will solve, then I will do. I want
hmm,
that kind of motivation in every student. That they are willing to learn something before they give up on something. You want to learn this concept, yes or no?
yes.
So you should do the proper solution. Huh? Because you
Hmm.
want to learn something, you should dedicate yourself.
Hmm. Sign.
Very good. Now this is the right answer. Excellent. So do you feeling something after getting the right answer?
No,
How it feels to get the right answer? Nothing.
no, it feels good. S-
Yeah. See, always make sure that in your life, when you deal with some problem, try to come to the solution, whatever it takes. In JEE preparation, I will just give you one simple suggestion that will help you throughout your life. Never stop because it's difficult. You must continue till you reach the answer. And in the
Mm.
beginning, even if you spend 1 hour, 2 hours, let me tell you, you can solve thousands of questions with ease. So these 1 hour, 2 hours are very important. Okay. Don't try to
Yes.
stay because you will think that okay, it's wasting my time. All right. So well done. And now you can leave and we can have this lecture. Thank you.
Thank you, sir.